Hi dear 10th class students, hope you are in the best spirit of your studies. Dear 10th class students, we are going to discuss today a very important concept through experiments, and that is called Faraday's experiment. Well, Michael Faraday, full name, he thought reverse of the Hans Christian Oersted. Hans Christian Oersted told us that when electric current is made to pass through an electric wire, a magnetic field is associated in the current carrying conductor. Michael Faraday thought reverse of this. He thought that if we can get magnetic effects from current, why not we get current from magnetic effects? Interesting. Now the question is, he performed one experiment for long time. Some people say 6 weeks, some people say 6 months. What is that experiment? Let me tell you here. He took 3 things: coil, galvanometer, and a magnet. You know, from magnetic fields are emitted. Galvanometer is there, coil is there. 3 things, not 1 day, not 2 days, not 3 days, weeks of time. No result. No result. See, what happened? One day in desperation, he had just thrown the magnet. The galvanometer shows deflection. He had just thrown the magnet, he had just thrown the magnet, right? In desperation, near the coil, galvanometer shows deflection. Now, he again repeated that, and again deflection. He again repeated that, again deflection, and he observed that if there is a relative motion between the magnet and the coil, the galvanometer shows deflection. And dear students, galvanometer shows deflection only when there is a current in the circuit, and there is a happy birthday of current from magnetic effects. How is it? When north pole of the magnet move towards the current carrying coil or solenoid, deflection takes place. This deflection takes place so long there is a relative motion between magnet and coil. तो ये deflection कब तक रहेगी? So long there is a relative motion between magnet and coil, means that either coil is in motion, magnet is at rest, or magnet is in motion, coil is at rest. The deflection stops if there is no relative motion. तो ये deflection रुक जाती है if there is no what? Relative motion. Hope it is crystal clear. Now see, if the polarity of the magnet is changed, if the polarity of the magnet is changed, means we are pushing south towards the coil, the deflection in the galvanometer is also changed. Means earlier it was like this, now it is like this. So dear students, one thing more very interesting. If we move the magnet faster, then what happens? The deflection is more. If we move the magnet slower, then what happens? Deflection is less. It means that the magnitude of the deflection is proportional to the relative motion. Magnitude of the deflection is proportional to the relative motion. More fast is the relative motion, lesser is the more fast is the relative motion, more is the deflection in the galvanometer. Slower the relative motion, lesser is the deflection in the galvanometer. Means more fast relative motion, more current. Slow motion, less current. Hope it is clear. If both magnet and the coil, they are at rest, no deflection. If magnet and coil both are moving relatively with respect to each other, there is a deflection. So what is the conclusion? When the bar magnet is moved away or towards the coil, galvanometer shows deflection due to current. Not due to current, due to magnetic effects. That current is known as induced current. Very interesting. So dear students, no current is induced in the coil when bar magnet and coil are at rest, or both are moving with the same speed in the same direction. If coil and magnet both are moving in the same direction with the same speed, no deflection. There is no deflection. So deflection takes place whenever there is a relative motion. Magnet polarity is reversed, direction of current is also reversed. The magnitude of the induced current increases if the relative motion is faster, is also increased. One thing more very interesting, try to understand. What is one thing more very interesting? That is what? This induced current is, when developed, then there is induced EMF, that is called electromotive force. EMF, induced electromotive force. You will put a question, what is an electromotive force? Which is basically known in short as EMF, is responsible to make the induced current to flow. It plays the role of potential difference as in case of a battery, but this is induced EMF is caused by what? Is caused by the relative motion between the magnet and the coil. Now dear students, हम क्या पढ़ रहे हैं? हमारे पास एक मैग्नेट है, एक कॉइल है. जब मैग्नेट एंड कॉइल के बीच में एक रिलेटिव मोशन होगी तो इंड्यूस करंट सेटअप होगा। इंड्यूस करंट सेटअप होगा वो कब तक होगा? जब तक मैग्नेट एंड कॉइल के बीच में रिलेटिव मोशन होगी। और इंड्यूस करंट का कॉज कौन होता है? इंड्यूस्ड ईएमएफ। एक और बहुत इंटरेस्टिंग बात मैं आपको बताता हूं स्टूडेंट्स। वो इंटरेस्टिंग बात ये है कि इसके अंदर होता क्यों है ऐसा, वो हम बहुत डिटेल में पढ़ते हैं 10+2 में, राइट? बट अभी 10th में इससे ज्यादा हमने नहीं करना। वी हैव टू डू ओनली दिस। होप इट इज क्लियर। सो बहुत सारे बच्चे ऐसे हैं जो स्कूल सिस्टम में पढ़ना चाहते हैं और उनको एक ऑनलाइन सपोर्ट चाहिए होती है किसी टीचर की, तो हम लोग हमेशा यूट्यूब थ्रू मैं अवेलेबल हूँ उनके लिए। तो मैं बहुत सारे बच्चों को मिलता हूँ तो मैं उनको यही बोलता हूँ कि बेटा अपने स्कूल सिस्टम में पढ़ो और पैरेलल में आप यूट्यूब से बहुत कुछ सीख सकते हो। जो बच्चे महंगी कोचिंग बेशक वो अफोर्ड भी कर सकते हैं, लेकिन वो चाहते नहीं है पढ़ना, वो चाहते हैं कि वो खुद से सीखें, खुद से अपने आप को कंडीशन करें, तो उनके लिए ये एक बहुत अच्छा प्लेटफॉर्म हो सकता है। अगर आपको लगता है तो आप जरूर इसको शेयर करें। और जो आप कमेंट करते हो ना, वो एक तरह की सर्टिफिकेशन हो जाती है कि ये लेक्चर अच्छा है या बुरा है। तो काइंडली शेयर इट, कमेंट, एंड आपको अच्छा लगे तो उन बच्चों को जरूर भेजो जो बहुत दूर गांव में है, बॉर्डर एरिया में है, जिनके पास इंटरनेट एक्सेस है बट वो बाहर नहीं आ सकते अपने घर से ना आए। हम उनके घर में जाके अच्छे से वही पढ़ाएंगे जिसके लिए वो बड़े बड़े मेट्रोपॉलिटन सिटी में जाके महंगी फीस देके पढ़ना चाहते हैं। होप इट इज क्लियर। तो विपिन सर इज फॉर द स्टूडेंट्स, बाय द स्टूडेंट्स and with the students. It is your channel, not my channel. Love you all. Thank you and keep sharing to your friends, particularly जो गाँव में है. Okay? Thank you. If you think it is a good teaching.